Welcome students. Today I will be teaching about algebra of sequences. Now let us first of all see what a sequence is. Okay, it is a list of numbers in a special order. So it should be a list of numbers and it should have a special order. So a list of numbers in a special order is called a sequence. Now let us look at an example. Consider the perimeter of the squares of sides 1 centimeter, 2 centimeter, 3 centimeter, and so on. Okay, so we have to find the perimeter of the squares which has sides of each 1 centimeter, 2 centimeter, and 3 centimeters, and so on. So what will be the perimeter of the square of side 1 centimeter? Yes, it will be 1 into 4, that is 4. And what will be the perimeter of the square of sides 2 centimeter? It will be 2 into 4, that is 8 centimeter. And what about the square of sides 3 centimeter? Yes, the perimeter will be 3 into 4, that is 12 centimeter. So we will get 4, 8, 12, etc. This forms a sequence. Now let us talk about terms. We consider the previous example, that is the sequence of the perimeter of the squares of sides 1 centimeter, 2 centimeter, 3 centimeter, and so on. That is 4, 8. Now we consider that is a sequence 4, 8, 12, etc. The numbers forming a sequence is called terms. So what will be the first term here? Yes, the first term is 4, the second term is 8, and the third term is 12. Now we can write it as follows. We write the position and the term. So in the first position the term will be 4, and in the second position the term will be 8, and in the third position the term will be 12. Okay. Now what will be the fifth term, or what about the 20th term? Can you find any relation? Yes, to find the other terms, we can actually find the relation between the position and the term. We have to see if there is a relation between the position and the terms. That is 1 and 4, 2 and 8, 3 and 12. We have to see if there is any relation between the position and the term. If we look at it in this way, we can say that 1 into 4 is 4, 2 into 4 is 8, and 3 into 4 is 12. So that is, they are the multiple of 4. So we can say that it is actually a multiple of 4. So if we can write the nth term, it will be 4 into n. So in algebra, we can say that the nth term of the sequence is 4n. And also in algebra, we can write the sequence, the terms of the sequence are normally written as x1, x2, x3, or y1, y2, y3. That is, the terms are, the first term will be x1, the second term will be x2, and the third term will be x3. And also we can write it in the terms of y. And now we have found the nth term, that is 4n. That will be the general algebraic form of the sequence. So we can say that the general algebraic form of the sequence of perimeter of squares with the sides 1 centimeter, 2 centimeter, 3 centimeter is xn is equal to 4n. So we just find the relationship between the position and the term, and we find the nth term, and that will be the general algebraic form of the sequence. Hope you understood. Now let us consider another example of the area of the squares with each side 1 centimeter, 2 centimeter, 3 centimeter, etc. So we are finding the area of the squares. Now what will be the sequence? Okay, first let's consider the square with the side 1 centimeter. What will be its area? Yes, it is 1 into 1, that is 1. And what about the area of the square with the 2 centimeter each side? It will be 2 into 2, that is 4. And what about the area of the square with each side 3 centimeter? Yes, it will be 3 into 3, that is 9. So what will be the sequence be? The sequence will be 1, 4, 9, etc. Now we have to find the relationship between the term and the position. So what is the first term here? 1. What is the second term here? 4. What is the third term here? It is 9. Now we know that each term, can you find any relationship with the position? Yes, each term is the square of its position. We can say 1 square, 2 square, 3 square, like that. So algebraically we can write it as xn is equal to n square. So what will be the algebraic expression for the sequence? Yes, the algebraic expression of the sequence will be xn is equal to n square. Hope you understood this this example. Now let us look at another problem. Okay, there are three matchsticks. Three matchsticks are required to make the first triangle. Okay, three matchsticks are required to make the first triangle. Five matchsticks are required to make two triangles. Okay, seven matchsticks are required to make three triangles. Now, then how many matchsticks are required to make four triangles? What about five triangles? And what about 10 triangles? Okay, we have to find out, and we also have to find out the algebraic form of the sequence. Okay, in the first triangle, how many matchsticks were taken? 3. And what about the second triangle? How many matchsticks were taken? 5 matchsticks were taken. And what about the third triangle? Yes, 7 matchsticks were taken. Now, what about the if we take 4 triangles, what will be, how many matchsticks will we have? Now, let us look at the sequence. Okay, the sequence will be like 3, 5, 7. Now, what will be the fourth term? That is, the fourth term will be the number of matchsticks required to gain the 4 triangles. So, let's see if there is any special order to here. We have seen it is 3, 5, 7. So, that is actually adding 2 to each term. So, when we add 2 to 3, we get 5. When we add 2 to 5, we get 7. So, the fourth term, what will be the fourth term? It will be, we just add 2 to 7. That will be, the fourth term will be 9. And what about the fifth term? Then we add again a 2 to 9, that will be 11. Now we have got the sequence. It will be 3, 5, 7, 9, 11, and we have the position of each term. And now we have to find the algebraic form. Okay, how will we find the algebraic form? We just have to find the relation between the position and the term. And we can see that it is actually, if in the first position it is 3. Okay, we actually multiply 2 into 1 and add 1. Then we will get the algebraic form of the sequence as 2n plus 1. That is, if we take as the second term, that is n is 2, we get 2 into 2 plus 1, that is 5. If we take n as 3, we will get 2 into 3 plus 1, that is equal to 7. And we can add like n is equal to 4, then we get 2 into 4 is plus 1 will be 9. And like that, we can find any term of the sequence. If you want to find the 20th term or the 10th term, we just have to substitute the n by 20 or 10, and then we will get those respective terms. Now we can easily identify the 10th term. What do? We just substitute the n as 10. Then we will get 2 into 10 plus 1 is equal to 21. So, okay, the first problem, write the algebraic expression of each of the sequence below. First, we have to find the algebraic expression of the sequence of odd numbers. Okay, first of all, we have to consider odd numbers. Okay, what will be the sequence of odd numbers? Yes, it will be 1, 3, 5, 7, etc. Here, what is the first term? What is the second term? What is the third term? The first term is 1, second term is 3, and third term is 5. Now we have to find the relationship between the position and the term. As we can see that it is actually 2 into n minus 1. So if we take as n is equal to 1, we get 2 into 1 minus 1, that we will get 1. And if we take n as 2, we will get 2 into 2 minus 1, that is 3. And if we take n as 3, we get 2 into 3 minus 1, that is 5. So the algebraic expression of the sequence is 2n minus 1. Now let us look at the next problem. That is, we have to find the algebraic expression of the sequence of natural numbers which leave a remainder 1 on division of 3. So first we consider the sequence. What will be the sequence? The sequence will be 1, 4, 7 and 10. Now we have to consider the terms. The first term will be 1, the second term will be 4, third term will be 7. Now we have to find the relationship between the position and the term. The first position is the term 1, the second position is the term 4, and the third term position is the term 7. Now we have to see what will be the nth term. So we can see that it is actually 3 times into a number minus 2. So xn will be 3n minus 2. That is, if we put 1 in the place of n, we will get 3 into 1 minus 2, which we will get 1. And if we put 2 in the place of n, we will get 3 into 2 minus 2, that is 4. And etc. like 3, 4, whatever number we take in the place of n, we will get that term. So the algebraic expression of the sequence is 3n minus 2. So we have also got the algebraic expression of the sequence. Now let us look at the next problem. We have to find the algebraic expression of the sequence of natural numbers ending in 1. Here the sequence will be 1, 11, 21, 31. So what will be the first term? It will be 1. The second term it will be 11. Third term will be 21. Now we have to find the relationship between the position and the term. If we write, actually it is actually 10 times into a number minus 9. So xn will be 10 into n minus 9. That is, if we place the n, that is, if we place 1 in the place of n, we will get 10 into 1 minus 9, that is 1. And if we place 2 in the place of n, we will get 10 into 2 minus 9, that is 11, and etc. So the algebraic expression of the sequence is 10n minus 9. Now we will consider the algebraic expression of the sequence of natural numbers ending in 1 or 6. First we have to consider the sequence. What will be the sequence? Yes, the sequence will be 1, 6, 11, 16, 21. What will be the first term? Yes, it will be 1. What will be the second term? It will be 6. Third term will be 11. Now we have to find the relationship between the position and the term. It is actually 5 times into a number minus 1. Look. So xn will be 5n minus 4. So if we place 1 in the place of n, we get 5 into 1 minus 4, that is 1, the first term. And if we place 2 in the place of n, we will get 5 into 2 minus 4, that is 6, that is the second term, and etc. like that. So the algebraic expression of the sequence is 5n minus 4. Okay, now let us consider the second question. Let's read the question. For the sequence of regular polygons starting with an equilateral triangle, write the algebraic expression of the sequence of sums of inner angles, sums of outer angles, and the measures of an inner angle and the measure of an outer angle. So we have to find the sequence of the sum of the inner angles first. So first we will consider the equilateral triangle, then the square, then a regular pentagon, then a regular hexagon, a regular heptagon, and so on. So first of all, let us consider the sum of the inner angles of the regular polygon starting with the equilateral triangle. What is the sum of inner angles of an equilateral triangle? Yes, it is 180 degree. And what about the inner angle of the regular the square? It will be 360. What about the sum of the inner angle of a regular pentagon? It will be 540, and etc. like that. So we will get the sequence 180, 360, 540, 720, etc. like that. Now what is the first term of the sequence here? First term is 180, second term is 360, third term is 540, etc. Now we have to find the relationship between the position and the term. We can see that it is 180 times. That is, the first term is 180 and the second term is 2 into 180, third term is 3 into 180, like that. So the nth term will be 180 into n. So the algebraic expression of the sequence will be 180 into n. That is the algebraic expression for the sequence of sum of inner angles of the regular polygon starting with equilateral triangle will be 180 into n. Now we have to look at the sum of the outer angles of the polygons. We know that the sum of the outer angles of each and every polygon is 360 degree. So what will be the sequence? Yes, the sequence will be 360, 360, 360. For every polygon, it is already 360 degree, the sum of the outer angle. Now what will be xn? Yes, xn will be just 360. Now let us look at the measure of each inner angle of a regular polygon. Each inner angle of a regular polygon is actually in the equilateral triangle. The measure of each inner angle is 60 degree. And what about the inner angle of a square? It will be 90 degree. And what about the inner angle of a regular pentagon? It will be 108 degree. And what about a regular hexagon? It will be 120 degree. Now we have to, how will we find the equation of the measure of each inner angle of a regular polygon? We have to divide the sum of the inner angle of the polygon by number of sides. We have the equation, that is 2n minus 1 into 180 degree is to find the measure of the sum of the inner angles, and when we divide it by n, we will get the measure of each inner angle of a regular polygon, and this is xn is equal to 2n minus 1 into 180 by n. So we have the algebraic expression over here. The algebraic expression of the measure of each inner angle of a regular polygon is xn is equal to 2n minus 1 into 180 by n. Now we have the algebraic expression here. Now let us consider the next. What was the next question? We have to find the algebraic expression for the measure of each outer angle of the regular polygon. So what is the outer angle of each regular polygon? What about equilateral triangle? What is the measure of the outer angle of a regular polygon? Yes, it is 120 degree. And what about a square? It will be 90 degree. And what about a regular pentagon? It will be 72. And what about a regular hexagon? It will be 60. Now the equation to find the measure of each outer angle of a regular polygon is 360 by n, where n is the number of sides. We actually divide the sum of the outer angles by number of sides. Then we will get 360 by n. So what will be xn? Yes, xn will be 360 by n. So the algebraic expression for the sequence will be 360 by n. Now let us look at the third question. Okay, the third question, look at these pictures. We have three pictures here and three triangles. The first picture is got by removing a small triangle formed by joining the midpoints of an equilateral triangle. Okay, the first picture is got by removing a small triangle. There is a small white triangle by joining the midpoints of the equilateral triangle. The second picture is got by removing such a middle triangle from each of the red triangles of the first picture. So the second triangle is obtained by removing, we have the three red triangles, and we have considered the midpoints of each red triangle, and we cut out a white triangle from each red triangle. Now, and the third picture shows the same thing done on the second. So we are actually cutting out the white triangles from the red triangles. The red triangle will be an equilateral triangle, and the white triangle will be cut out by joining the midpoints of this equilateral triangle. Okay, now there are some questions. The first question is, how many red triangles are there in each picture? So we can count. In the first triangle, how many red triangles are there? Yes, that is 3. And what about in the second triangle, how many red triangles are there? It is actually 1, 2, 3, 4, actually 9. And what about the third picture? There is actually 27. Now we can find actually in a simpler way. There are actually 3 triangles in the first 3 red triangles in the first triangle, and it will be actually 3 into, there is actually 3 into 3 red triangles in the second triangle, and 3 into 3 into 3 red triangles in the third triangle. That is 3, 9, 27. So the sequence will be 3 into 9, 3, 9, 27, etc. Now the next question is, taking the area of the original uncut triangle as 1, compute the area of the small triangle in each picture. So the original uncut triangle has area 1, 1. So we have to find the smallest triangle in each picture. So in the first triangle, how many triangles are there? There are 4 triangles. So what will be the area of the one single small triangle? It will be 1 by 4, since 1 is the total area of the uncut full triangle, and there are 4 small pieces. So we can write the area of one small triangle as 1 by 4. Now we consider the second triangle. How many small triangles are there? What is the total of the small triangles? It is actually look at the first triangle. The first triangle is actually 4 times the second triangle. So the total number of the small triangles will be 4 into 4, that is 16. So what will be the area of one small triangle? It will be 1 by 4 into 4. Now consider the third triangle. The third triangle, how many total small triangles are there? Yes, again, the second triangle is also into 4. We'll get the third triangle. That is 4 into 4 into 4. There will be that much small triangles. Now the area of one small triangle will be 1 by 4 into 4 into 4. Now let us look at the sequence. What will be the sequence here? The sequence will be 1 by 4, 1 by 4 square, 1 by 4 cube, etc. Now the next question is, what is the total area of all the red triangles in each picture? In the first triangle, we have 3 red triangles. See, 3 red triangles, and each small triangle has an area of 1 by 4. So we can say that the total area of all red triangles in the picture will be 3 into 1 by 4, that is 3 by 4. That is, we have a total of 4 small triangles in the first triangle. So one small triangle will have the area of 1 by 4, and we have 3 red triangles. So the total area of all the red triangles in the picture will be 3 into 1 by 4, that is 3 by 4. Now we consider the second picture. Okay, in the second picture, we have how many red triangles? We have 9 red triangles, and we have found in the previous question that each small triangle have area of 1 by 4. So the area of the total 9 red triangles in the second picture will be 9 into 1 by 16, and we can write it as 3 square by 4 square. Now we consider the third triangle. In the third triangle, we have total of 27 red triangles, and each small triangle will have the area of 1 by 64. So the total area of all red triangles in the picture will be 27 into 1 by 64, that is 3 cube by 4 cube. So what will be the sequence? Yes, the sequence will be 3 by 4, 3 square by 4 square, 3 cube by 4 cube. And what will be the algebraic term of the sequence, algebraic expression of the sequence? It will be 3 raised to n by 4 raised to n. And now we have to find the algebraic expression for these 3 sequences of 3 by the continuous series process. So we have got 3 sequences. The first sequence is 3, 9, 27. That is actually the number of red triangles in each picture, that is 3, 9, 27. And we can write it as 3 raised to 1, 3 raised to 2, 3 raised to 3, etc. And then what will be the nth term? It will be 3 raised to n. So the algebraic sequence will be xn is equal to 3 raised to n. Now we consider the second sequence. That is actually the area of one small triangle. The second sequence is 1 by 4, 1 by 4 square, 1 by 4 cube, etc. So xn will be, what will be xn? 1 by 4 raised to n. So the algebraic sequence of the second algebraic expression of the second sequence is xn is equal to 1 by 4n. And what about the third sequence? The third sequence is 3 by 4, 3 square by 4 square, 3 cube by 4 cube, etc. And what will be the nth term here? It will be 3 raised to n by 4 raised to n. So the algebraic expression of the third sequence is 3 raised to n by 4 raised to n. I hope you all understood the algebra of the sequences and how it is also formed, and how we can find out any term using the algebraic sequence. So thank you.